we saw in the last video that if we had a distributive law, we could calculate dot product very easily. So the question really becomes, why in the world is there a distributive law when in the definition of dot product there's nothing about that? And you would think that with plus the cosine addition formula would come into play, which would just be hideous. It doesn't, which is really, really cool. And the idea is we can actually do this whole thing geometrically if someone actually just shows us the right picture. So this is what we're going to do. What we're going to do is we're going to draw the vector W being way out here like this. And how about the vector V being here like this, and the vector U being here like this. And we're going to make sure we have little arrow thingies here that sort of look like little arrows, and start trying to do geometrically what everything is. Now remember how we add U plus V geometrically. We're supposed to make a nice parallelogram here like this, so that this vector here, let's see here, this vector here is going to wind up being U plus V. Good. Now, what are we going to do? Well, remember the dot product is actually about shadows. So instead of actually trying to show the distributive law, I'm just going to look at the shadow of each vector U, V, and U plus V on a W and see what we can say. Now, what is the length of the shadow of U onto W? It's just this little length right here. And we actually know exactly how long that is because we have a projection formula. That should be U dot W over the length of W. Now, what is the length of V? Well, if I use V here, that's going to overlap, and I don't want that. But from here to here is also the vector V. So what I'm going to do is take the shadow of this vector down onto W, and I'm going to get this length right in here. And that's going to be V dot W, length of W. And now what I want is the length of the green vector U plus V onto W. Well, that's going to be this whole length right here. And that length right there is going to be equal to, by definition, well, not by our, sorry, it's by our formula. That's U plus V dot length of, I'm sorry, W over length of W, like that. So that's what we have so far, is that this little length right here is U dot W over length of W. This length right here is V dot W over length of W. And the big long green distance is going to be U plus V dot W over length of W. Now we don't have a distributive law yet, but what we do have is what the picture gives us. Ready? This little length plus this medium length is clearly equal to that whole length. So just looking at lengths, we get that U dot W over length of W arrow plus V dot W over length of W equals, I guess I can make it the big green distance, it doesn't matter what color I write it in, and at least it's descriptive, right, is equal to U plus V dot W over length of W. So at least in terms of shadows, that resembles the distributive law. We no longer need the picture. What we're after is the distributive law. Well, the distributive law I want looks like this, right? It looks like U dot W plus V dot W equals U plus V dot W. I don't have that yet. All I have is this one up here. And the question is, if we have this equation here, what will we have to do to both sides to get the distributive law I want? Well, actually, now that's really easy. We're just going to multiply both sides by the length of W. If I take this and I multiply both sides by length of W, which is just, really it's arithmetic, right? I get that, which is the distributive law. Once we have the distributive law, we have our formula for dot product, and we start calculating dot products. We can start calculating angles. We've got all sorts of wonderful things. But the key to the whole thing is this distributive law, which really came from the length of shadows, which was the problem that dot product was invented to solve anyway. So it's nice supporting going back both ways. Very happy about that. We now have the distributive law for dot product.